Hey everybody, so today we are starting our unit of circles. We're going to start off by talking about a couple of new things. If you need to review some of the parts of circles, I have uploaded and posted on our Schoology page a document containing all of the vocabulary that goes with circles. So make sure to check that out as a little review before clicking on through this video. Now, the first thing we're going to talk about today is arc length, and then we're going to talk about a couple of different ways that we find the length of an arc or the measure of an arc. So to start off with today, we are going to talk about just when I have two radii coming off from the center of my circle and the distance between the two radius. So to start off with, we have our arc length formula, which we write as the length, my arc length, is equal to x being our degree measures of our arc, times c, which is our circumference of our circle. Remember that circumference is either 2 pi r or pi times the diameter. And we're going to divide that by 360. And where we get this from is because x is the measure of degrees in between those two radius. Now, this is just one part of the full circumference around my circle. So I know what that one part is by taking it multiplied by my degree measure for my arc. And then I can divide that by 360 to break it up into the parts that would be left over. Remember, a circle makes a full 360 degrees. So we get this by taking the part that we want times the whole, dividing by the total part. All right, so that's our equation. Let's go through a couple of examples. So the first one, we want to find the length of the bolded arc measures here. Now, to do that, we're just going to follow what this formula tells us. So we'll have our length equals x, which is our degrees, 107, times the circumference. Well, let's find the circumference real quick. C equals 2 pi r, and in this case, r is 6 meters. 2 pi 6. So really this is 12 pi. So I'll multiply 107 by 12 pi and divide it by 360. So we'll get L equals, take out our handy dandy little calculators here. So we take out those calculators and we take 107 times 12 times, now we need to figure out where is pi. We want to be as exact as possible. Well, you'll notice, if you look really closely, right here for my caret key, for my second function, that's actually pi. So we'll type second caret. And that gives us our pi for our expression. And I'll hit equals there, and then divide by 360. And I get that my length would be 11 point, and let's see, we wanted to round to the nearest hundredth this time. So we would get 11.21 meters. All right, let's try this next one here now. We have a radius of 15 and a degree of 38. So our length equals 38 times our circumference divided by 360, and our circumference is going to be 2 pi 15, which is 30 pi when I take that 2 times 15. So 30 pi. Again, in my calculator, I'm going to type that in, 38 times 30 times second pi divided by 360. I get 9.948, so I can round my length to say 9.95. And don't forget your units of inches. We'll take a look at some more complex examples in the next few lessons, but for today, that's all we'll do for arc length. Now we're going to move on to the next way that we can see these arcs. All right, so now we're going to take a look at what happens when we have an inscribed angle and we try to find the arcs using those inscribed instead of having our radius. So now we call these sides like BA or BC, we call those chords. They don't cut through the middle, so they're not a diameter, but they still stretch from side to side on my circle. So a couple of other things to talk about. An inscribed angle, well, what does that mean? It's the angle that is its vertex on the circle with two sides that are chords. So like I said, we have point B is our vertex, and we have BA and BC that are two chords that connect not through the center point of our circle, not through its center, but off to the sides. The next thing is an intercepted arc. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. So that intercepted arc is going to be this part of my circle from A to C. Now, the measure of that inscribed angle is actually equal to half the measure of the arc. So we can write an equation here. If I know what this angle ABC is, that's equal to 1/2 the arc AC. And we write that as an arc. Now, what happens though if we look at that intercepting a diameter? Well, if we have an inscribed angle that intercepts a diameter, then it's actually a right angle. So the BAC, so from A here, we would have a right angle. BAC is 90 degrees. So the 2 points that connect each other to make the diameter would be like our hypotenuse of our right triangle. Our diameter is our hypotenuse, and that'll come in handy once we start connecting our circles to our triangles. One last thing to talk about, if we have two inscribed angles that intercept the same arc, then the arcs are congruent. So if I look at angle ABD, we're talking about this one right here, angle B, that's the same as ACD. These would be equal angles. Now, the chords might look longer, however, they would be coming off at the same angles. They have to use the same angle in order to meet at both A and D. They're just a mirrored image, and one's a little bit bigger in terms of the leg measures. So let's go through a couple of examples of how we find and use what our arc measure is with what our angle measure is going to be. So for this first problem here, we're given that our arc measure from W to Y is 62 degrees. Well, we can use our first equation that we have here to say what angle WXY is going to be. So that's this angle here. We said that my arc measure is 1/2 of my other angle. So if I'm trying to find what angle WXY is, we know that that's equal to 1/2 of my arc measure, which is 62. So the measure of my angle WXY, well, 1/2 of 62, I know that that's going to be 31 degrees. Let's take a look here at our next measure. We know that the measure from D to EF for our angle is 113 degrees. So this time we're given our angle measure, And our angle measure is 113. And they want us to find the measure of our arc from DGF. So this side over here. Well, we can do that by knowing that 1/2 of DGF is equal to 113. In other words, if I want to know what my arc measure is going to be, I need to multiply the angle I was given by 2. So I'll have 2 times 113 gives me my arc measure, DGF. And 2 times 113 is going to give me 226. So for your assignment today, you're going to look at a couple of different examples similar to these ones and the ones that we viewed before. So if we look back at these other examples that we were talking about, where I had my arc length and my angle isn't just an inscribed angle that uses chords, if we're using our radius from the center point like this, we're already looking at just half of this circle. So if I'm trying to find the angle measure like we were over here, I'm not all the way across my circle anymore. I'm only halfway across it. So when I have the arc length sizing here, this is actually going to be my angle is equal to my arc measure. So I could label this, let's say this is X, this is Y, this was Z. I know that angle ZXY is actually equal to the measure of my arc Z to Y. Because it only covers half the distance that a normal inscribed angle would cover, this is going to be equal to my arc measure. So we would say that 107 is my measure for Z to Y. So with that, you should be prepared to do our assignment for today. We'll be continuing this topic of circles for the next couple of times before we get into volume and surface area. Let me know if you have any questions.